Good morning or good afternoon, everybody, and welcome to our webinar, Smart Traceability, the core of a successful systems engineering discipline. My name is Cecilia Karlsson, and I will be hosting today's webinar. With me, I have Jose Fuentes, Chief Operating Manager at the Reuse Company, and he will do the presentation about Smart Traceability. This is the table of contents for the webinar. First, we will have a short presentation of the company and the presenter. Then we will see what traceability is. Next, Jose will talk about traceability in complex systems. After that, we will take a look at the tool Traceability Studio. And finally, we will have some time for questions and answers. So first, a few words about the Reuse Company. The Reuse Company was created in 1999 as a spin-off from a university in Madrid, Spain, by system and software engineers. Our headquarters is in Madrid, but we also have an office in Stockholm, Sweden, and a delegation in Tokyo, in Japan. In 2021, we are planning to open an office in the US. Our mission is to promote a reusable, scalable, and global solution to a smart and interoperable systems engineering environment. And we do this by offering a semantic, knowledge-centric approach. The Reuse Company is also called TRC. We like to say that it's easy to remember if you think of T like in traceability, R like in reuse, and C or almost Q like in quality. You can also apply these concepts to other topics. Now let me introduce you to the presenter. Jose Fuentes is the Chief Operating Officer at the Reuse Company, and he has been the product manager of the Systems Engineering Suite tools for more than 5 years. He has the INCOSE CCEP certification and is graduated in the INCOSE Institute for Technical Leadership. He is a member of the board of the Spanish chapter of INCOSE, and he is also an active contributor to the INCOSE guide for writing requirements. So let's start then with today's topic. Hello, Jose. Please go ahead.
Hello, Cecilia. Can you hear me well?
Yes.
Okay, so thank you, Cecilia, for this lovely introduction, and welcome everyone to this webinar. For those of you who already know us, I'm a little bit changing topic. Normally, my topics are more related with requirements and requirements quality, but today I would like to introduce you to this concept of traceability, mainly because traceability is everywhere. Traceability is, for instance, when you visit your preferred restaurant, there is some sort of traceability there, where you want to know everything about the food you are having, right? So we can define traceability like the capacity to find where a product was made, what were the raw material that were used, and what were the added components that were used in the manufacturing of this item, how it was produced, where it was produced and stored, how it was released, and you want to know all this along the logistic chain from beginning to the end, right? So this is the idea. It could be the idea for your preferred pizza, if you are a pizza lover, or it could be for a car, or it could be for whatever system you are dealing with. So in order to be a little bit more precise, and probably because of my background, I always like to check definitions in the standards related to requirements. So I found that this description for traceability in the Ieee 830, this is the standard focused on requirements management. So it defines or tell us that a software requirement specification is traceable if the origin of each of its requirements is clear, and if it facilitates the referencing of each requirement into future development or enhancement documentation, right? So clearly, in order to even to check and to verify the quality of our requirements, we don't only have to focus on the way it is written and on the messages that are included in our requirements, but also aiming to the completeness of our requirement specifications. We also have to think of the traceability to other model elements. If I continue with this, the same standard, and now I focus on another characteristic, not only completeness, but now verifiability of our requirements, then we can read that requirements is verifiable if and only if there exists some finite cost-effective process with which a person or machine can check that the software product meets the requirement. Clearly, in here you have an implicit reference to the need of having traces between requirements and tests and test definitions, right? So we have two dimensions: traces among requirements from the top level needs, let's say, to the technical specifications, the technical specifications, and also traces towards the items that are defining the verification of our requirements. So we can think of these two dimensions, and we can think of these kind of traceability matrices. In this example, you have requirements here on the top, right? And you have test cases in this column, so that you can come out with a different number of crosses here and there, representing how each of those requirements are traced by means of test case. This is an end-to-end matrix. And of course, as I mentioned, this could fit with the definition of traceability that I was given in the previous slide. So no, I deserve this World Cup, let's say, because it could be good as a first step aiming at traceability. It allows to check where every requirement comes from, supposing that we include not only this matrix, which is mapping requirements with test cases, but if we also have requirements at different levels, then we could think that it allows to check where everything is coming from with that the top level needs. It allows to check completeness for our tests, of course. It ensures that implementation meets the specifications somehow. It could be, let me say in this way, it could be enough for some projects, for some software development, basic small projects, let's say. But clearly, this is not enough in complex projects. It doesn't support the decomposition of our requirements, or it doesn't support when we start with the design, architectural and design phase. And of course, it doesn't satisfy standards and best practices like ARP 4754 or the DO related procedures or the ISO 26262 standards and so on and so forth. So we need clearly, this could be a good starting point, but we need something else. So how should we define traceability in complex projects? So let me focus on safety critical projects, and let me focus on INCOSE. And I have checked this process of requirements definition, system requirements definition. In this process, we have some inputs that are clearly related with high-level requirements. So stakeholder requirements. In order to define the system requirements, I need the stakeholder requirements. And of course, I need the stakeholder requirements traceability and this requirements verification traceability matrix as well, right? So this is the input for this process. And by means of mainly the activities of analyzing system requirements, but mainly managing system requirements, mainly with this, we come out, of course, with system requirements and with a new version of these traceability matrices, right? So all this is the output. So clearly, we have traceability as the input, and we have traceability also at the output, and not only the requirements themselves. So this is something clear. And of course, in the definition of this process and managing the activity of managing system requirements, we have here the idea to establish and maintain traceability between the system requirements and the relevant elements in the system definition. That is, stakeholder requirements, architectural elements, interface definitions, analysis results, verification methods or techniques, and allocated, decomposed, and derived requirements. So that is requirements at different levels that has to be traced by means of different types of traces, right? Continuing with another very well-known definition of what requirements traceability is. I like this because I think it is very well-known, telling us that requirements traceability is the ability to describe and follow the life of a requirement, both forward and backward direction. That is from its origin through the development and specification to subsequent development and use, through periods of ongoing refinement and iteration. So to me, this is a very important definition because, as you all know, requirements management is an iterative process. So we have to bear this in mind when we think of traceability. We have to think of the idea of different iterations. But what is even more important to me in the definition of requirements management is not only the idea of iteration. Of course it is, but it is to me the one which is even more important is the idea of recursion. And this is what makes somehow the traceability a complex activity, right? Because all along the life cycle of our systems, we will not only deal with system requirements at for one specific system. It will be that our system will be further decomposed in subsystems and components and parts and whatever, depending on the method you follow to do that. And that this means that you will deal with different system requirements documents, right? So this is the idea of recursion. And of course, it is not only that you have to trace in let's say in a kind of two-dimensional space, but also you have to trace in a three-dimensional space due to this recursion or the property of recursivity in the definition of system requirements, right? So this is, as I said, what makes this discipline a little bit challenging. And but anyhow, this is the discipline is key for different industries. Let me just focus in a couple of industries. First of all, the civil aircraft industry. So these are some of the processes that suppliers must provide to show that they are meeting with all the goals and objectives in the ARP 4754. So among others, we find a requirements management process, of course, including traceability and allocation. Change management, this is another challenging topic, not only the recursion, but also the changes along the life cycle. And of course, the requirements verification process, which is the topic of some of the tools in our tool suite, right? Continuing with this very same practice, the ARP practice, it defines a safety requirement as requirements that are defined to prevent failure conditions or to provide safety-related functions, should be uniquely identified and traceable through the levels of development, right? So the idea of traceability, as you can see here, is everywhere. If I move into the automotive industry with the ISO 26262, then in the definition itself of what safety requirement is, it comes the word traceability as well. So it is safety requirement shall be traceable with reference being made to each source of a safety requirement, upper level and lower level, right? So the idea of traceability is everywhere. However, as I said, traceability is not an easy task. Normally, you will find ecosystems or environments like this. So it is very rare finding a complex system that is developed with one single tool or which is specified with one single tool. Normally, what you will find is a complex ecosystem with tools that doesn't necessarily have to reconcile and to work together. So somehow we need some sort of layer here to integrate tools for different disciplines, from requirements or needs, modeling, simulation, physical modeling, logical modeling. So all this has to be reconciled in one single ecosystem of tools, right? And the other challenging topic that I was mentioning is the change analysis or the change impact, right? Then it always comes to my mind this commercial it was very famous in Spain some years ago for these insurance companies, Zurich, because change happens, right? So this is normally what we find in our projects. In our projects, we find that changes happen. It could happen for many different reasons, mainly changes in scope, controlled changes in scope. Of course, controlling this is key element of traceability to control how all these changes are managed. Normally, what you will find is that you start with a bunch of initial original requirements. Then across the life cycle of your systems, you will find that some of these requirements are removed. It could be that are removed because they are out of scope or they are duplicated or whatever. So some will be removed or changing control in a controlled way, changing the scope. Something is not needed anymore. It could be that some other of your requirements will be changed across the life cycle, and it could be that in a controlled way, some new requirements arise. It could be because of change of scope in a controlled way, or it could be because of new regulation or whatever that make us come out with new requirements. So because of all this, it could be that I start with these requirements in here, but I end with those requirements there, right? So controlling this is the responsibility to the traceability and change impact process. So what are the goals for traceability process in this kind of environment? It depends on the standpoint and it depends on your role in the project, right? It could be that for project quality, what traceability provides you is an answer to the question: are all the requirements properly tested? So it is clear. Also the completeness. Have we considered every high-level requirement? Have we created all the expected work products following those requirements? For a project manager, we could be more focused on scope management and the idea to avoid, as I mentioned before, scope creep when things or changes are not under control. It's clear that we need a reference to the source for every of the requirements that are eventually implemented. Of course, traceability provides visibility and impact analysis, and it enables the collaboration of the different roles within the projects, including requirements managers, architects, quality people, designers, testers, and above all, of course, project manager, as I mentioned before. So the idea of a typical coffee meeting in a project could be something like this. One guy requesting, okay, guys, I need a project status. The other guy say, oh, yeah, sure, we are done 90%. So this is the typical 90-90 rule that most project managers know pretty well. And of course, in order to provide this real visibility, we need tools like Traceability Studio. This is key. So our approach is to start with a different combination of tools. So Traceability Studio will not aim to replace all these tools across the life cycle. The idea is to keep working with all these tools, but being capable of connecting all of them together under the form of our typical ontologies, let's say, and our project ontologies. So here remains the same idea for those of you who already know us pretty well. You know our ontology oriented approach. So all this is indeed developed under the form of one of our ontologies, but ruled now with this new tool, Traceability Studio, right? So this is the idea. So as a kind of quick summary, traceability in complex projects, pros and cons. Of course, it is a must in every system which is kind of safety critical or complex system. It is requested by standards and good practices like the ISO 26222 or the ARP 4754, and of course it provides visibility in every single complex project. However, the cons, it is normally a tedious and manual task and involves a connection to tools that are not necessarily connected, right? So how to tackle these pros and cons. Traceability Studio. Let me show you some of the key characteristics of this tool. I have created these 4 main pillars to show you quickly the main characteristics of the tool, starting with connections. So we need to extend as much as we can the number of connectors to different tools, and not only requirements, but modeling, simulation, physical, logical simulation, and other tools, right? So this is the current list of connectors we have developed in version 18 of our tool. There are many others that are coming very soon when we release version 21 of our tool in 3 months' time from now. You will find many others. And of course, if you are interested in including your own tools or the tools that you normally use in your life cycle, then please let us know, because integrating new tools is, because of the architecture of our system, implementing new tools is very straightforward. And at the end of the day, a traceability project can look like this, let's say, where each of these boxes here is representing a document. Each of the arrow in the diagram is representing a traceability module, where for each of the documents you can see things like this is a Word document with 6 goals coming from a project chapter, a stakeholder requirement specification in Excel 61, then system requirements in DOORS, or system requirements in DOORS or DOORS next generation, models in Capella, risk or test case definition. So all these conform small yet regular project, right? So the idea is that the tool allows you to establish as many traceability modules as needed. Then the regular traceability management. In our approach, you can define with the tool. This is now another screenshot of the tool. You can define as many types of links as you wish. So whenever you establish a new link, a new trace, you can pick one of the available possible traces, so that in the same module you can join together different type of traces. Each module defines how many different traces are enabled in this for the module. This is the complete list, but you can extend this list according to your own methodology or your own way of working with the different elements, right? Then manually creating a new trace is very straightforward. So the tool, when you open a traceability module, you have 2 sides in the screen, the source and the target for this traceability module. So creating a new trace is just as simple as first pick with what type of trace you want to create. Second, select the source, select the target, and click to create the new trace. And now the new trace is represented here. So it is very straightforward, let's say. And of course, this enables you the possibility to find missing traces, or to find or to show impact analysis in a graphical or tabular way. So this is our graphical representation for an impact analysis, where I start here with goals, a definition of goals that derives into stakeholder requirements, and in turn they derive into system requirements, right? So all this is very straightforward to obtain with Traceability Studio. However, what is most impacting on the features of our tool is the possibility to come out with a semantic approach to enhance the capabilities of the tool, and to help and to aid the people in charge of managing this tool. So if you know us, you know our semantic approach based on ontologies, allowing to do many different types of actions towards the quality of our requirements, but also we have implemented our semantic approach also on top of Traceability Studio, and this is what makes our tool unique, I think, right? So briefly speaking, this is an ontology for us. Of course, there are plenty of different definitions for what an ontology is. This is the one that works better for us, starting with the definition of the control vocabulary in your systems, both general English or French or German or Spanish or Swedish or whatever of the languages we provide support to, but also mainly domain-specific vocabulary. I will mention this in a minute. Then the second layer is, while the first layer is just defining individual entries in a domain-specific dictionary, the second layer is aiming to link all the elements in the first layer together by means of different types of links. Now, when I speak about links, I'm meaning links among concepts and not links among work products, right? So Traceability Studio will deal with linking work product or work items. However, in here I'm meaning our ontology representation. So, what I'm meaning is just linking the concepts in the control vocabulary, right? So we have two mechanisms in this second layer. One is linking by means of different types of links, and the other one is grouping together by means of the meaning or by means of the nature of the different concepts in the control vocabulary. Actors will be grouped together, name of systems will be grouped together, name of signals will be grouped together, and so on and so forth. Then layer 3, since we are aiming to really understand what is the meaning of textual items, especially for requirements, but it could be also for other kind of textual artifacts. So we need some sort of definition of the grammar for a well-formed requirement or for a well-formed test case or whatever textual definition, right? So this is what we call pattern. I have in the coming slides, I have a couple of examples of this. Then it comes, let's say, the part where the tool is doing the magic and the smart activities. First, with the stage that we call formalization, where we start from an actual textual input, and by means of the patterns, we transform this input into a semantic graph that is following our own SRL, system representation language, but this is just a kind of type artifacts, type boxes, and type arrows. So it's classical semantic graph. And then once the textual artifacts are formalized properly by means of these semantic graphs, then it comes the reasoning. The reasoning for quality checking, if you have followed our webinars recently, is just finding issues in a specification and providing you with tips and hints to enhance the quality of your specification. However, reasoning in here could be different things. So if we start with the basic traceability management, mainly defining traces manually, on top of this, thanks to the semantic characteristics, we can provide semantic automatic suggestions of new traces, as I will try to show you mainly during the live demo, or an advanced and smart management of suspicious links. The idea that every change in every requirement is equally important is not that true. Sometimes what we just do is just a minor change in a requirement, but normally these changes provoke a change in the date or a change in the text itself, and the tools are detecting this as a suspicious change. However, most of the times these changes are just minor changes that are not changing the meaning. So what we need is a tool to distinguish between actual changes and or from minor changes, right? So this is an example of the ontology that I was mentioning before, the 5 layer. Remember, here you can find 4 out of these 5 layers. The first one is just the vocabulary, where we can distinguish clearly between what is to the right of this vertical line, which is the generic English. All this is coming out of the box in every of our installations. So whenever you install our tools, you are also installing a small database with an ontology. This ontology includes everything that you can find here to the right of this vertical line. So generic concepts in English, including small words like shall, the, prepositions, adverbs, determiners, and so on and so forth. Then, of course, it comes for you to define a more domain-specific vocabulary. So since it all depends on your current projects or current activity, then probably you will find nothing about your business domain in an out-of-the-box database. The good news is that you can use one of our tools, Knowledge Manager, to automatically suggest the content for these two layers, the vocabulary and the system conceptual model, and having a semi-automatic population of both layers, just starting from your own documentation, from legacy documentation, right? So in here, if I was dealing with a radar system, then of course I should have to add concepts like radar, target, hit, whatever. Then in a second layer, we have things like, remember, linking together or grouping together the concepts that are coming from the previous layer. In here, in the generic English side, we have clusters like entities. Normally, this is something that we will use a lot in our requirements, the naming entities. However, entities are normally domain-specific information. So normally what you will find is that the cluster, we call this grouping, we call it, technically speaking, we call these groups clusters. So and normally are represented with these angle brackets here. So the cluster will be there, but eventually you will have to populate and to put inside what are the entities in your business domain. You will find different types of relationships. Of course, you can extend the types of relationships, but some of them are fixed types that will be always there, including, for instance, the equivalence, so that you can say something like a hit in my domain is an equivalent to a target, is a kind of synonym. Then we have other types of relationships, like hierarchical relationships, saying that both radar and sonar are types of electromagnetic device that in turn are name of systems. And if you can notice, the head of this arrow is a little bit different. It is not a triangle, it is a kind of a diamond, representing that a radar is made up of, among others, of a display, receiver, transmitter, and so on and so forth, right? So you can define what is the schema of your system. Of course, for all of these domain-specific block, we offer two possibilities, as I mentioned. The first one, mentioned before, is requesting KM to automatically analyze existing documentation or models and extract information from there. And the second one is just to have live connections, real-time connections to modeling tools, so that all these domain-specific information, if you are dealing with classical or the typical UML or CSML modeling tools, the idea is that you can ask our tools just to connect to your modeling tools, so that all this information can be populated automatically from there. Then it comes to the definition of patterns with a structure. So this could be a basic pattern, including as a subject one of the name of a system, the system, or this star here means any of the child of this system shall. Then as the main verb, I can choose between just a very specific verb like or cluster like detection, only these two will fit, or I can be a little bit broader and say action, and then I also allow other actions like to emit, to receive, or to connect, right? Then I'm at a minimum rate of whatever. So this is a performance requirement example, right? So so that whenever we find an actual textual requirement, then we can automatically in this layer 4 come out with a formal representation of this text. So this could be the formal representation of this actual textual requirement. And then in the 5th layer, it comes the reasoning. The reasoning could be something like taking these two requirements at two different levels of abstraction. At a first glance, it seems that these two requirements are different because this is larger, this is shorter. But after a second time you read these two requirements, then you realize that this is passive voice, this is active voice. But at the end of the day, they are almost meaning the same. So this is what you can guess very quickly as a human reader, let's say. So whatever you wish is you would like to have enough information in the ontology. Remember the information I was populating in the previous slide, so that it is not only that you as a human, as an engineer, you can decide that these two requirements are equivalent, but you also would like the tool to tell you that these two requirements are equivalent as well, right? And this is what we get just by having the taxonomies and the PBS representation that I was showing you before. equivalences between target and hit, and grouping together by means of the meaning of the actions, grouping to identify, to discover, to detect, and to find as to similar actions. With all this information beforehand in the ontology, you will have you can have the tool automatically thinking that these two requirements are pretty much alike or similar. So and this in turn allows you to suggest automatically traces to your system. So first taking the source and taking the target, where both source and target could be textual documentation, or could be databases with requirements or tests or whatever. It could be also models, especially for the target here. Then we can apply all these semantic tools to by means of the formalization and by means of gradual semantic search that you can graduate if you want fully equivalent requirements or a little bit less than fully equivalent or whatever. You can find automatically traces of requirements at different levels of abstraction. Or if you have two requirements documents and you have requirements at both sides fitting the same pattern and having the same, for instance, the same condition as, for instance, a particular state, something like when system is in state 1 and whatever happened, the system shall do whatever. If you find something similar at both ends of this traceability, then you can have the tool suggesting you that there should be some sort of derivation between these two requirements. Or if you have a product breakdown structure definition, and you find that in here in the source I am defining physical property for an element which is the parent of another element which is described here in this other document, and in here you find another requirement which is describing the same property, let's say the power consumption of the full system and the power consumption of one of the subsystems, then clearly you can use our tool to do some sort of identification of allocation traces, right? Or thinking of the possibility of naming here, for instance, a name of a state, as I'm meaning here, and tracing to the target as a model, having the model as a target. Of course, this state, if this is the state that I am mentioning in this requirement, the tool can suggest automatically traces from the requirement to the state in the model. And I use here, I have put ellipses here just to mention that we have plenty of other algorithms, and what is more, you can come out with your own algorithm to identify new traces. And then reporting, I will show you the reporting mechanism in the demo, right? So finally, before the demo, just to mention that traceability is one more tool within our ecosystem of tools in version 18.5, the current version still today. Traceability Studio works together with Knowledge Manager for the definition and management of the ontologies, with RQA for the static quality checking of the elements at the left-hand side of the V model, V&V Studio for the verification and validation of every single element left and right side of the V, and the authoring tool to have real-time quality checking of your textual items, right? So let me go for the demo now. My demo is pre-recorded. It's a little bit long, so I will skip some blocks, but this is now Traceability Studio, where you can define different types of connectors. You can connect to all the tools that I was representing in my previous slide, requirements tools, modeling tools, Word, Excel, and some others, right? So in this example, I will create connections to, for instance, in this case, this is a connection to a doors repository where I just provide my credentials, and then I just pick a specific project, and then all the modules, all the formal modules in this project will be listed here so that you can use them in traceability modules. Then the same for Excel. By the way, the connections that you can see here are the same connections that you can establish with our tool RQA. So if you know how to create a connection in RQA, then of course you will know how to create the connection in here. And by the way, the connections you create here in Traceability Studio are shared with the tool RQA, so that you only have to create the connection once. So this is the mapping for Excel. So it is a very straightforward to create a connection to Excel, just mapping the columns. Then here I show you how to create a connection to a Word document. This is a project charter. This is a plain, normal document. There is no need to deal with special styles or whatever, because we have implemented different types of or ways to parse a textual document, including styles, including regular expressions, including patterns, right? In this case, I am using kind of a specific code following a regular expression. This code is coming out of the box with your database, so that you can use it, or you can even change this regular expression so that you can catch whatever you wish in your document. But at the end of the day, when you connect to a Word document, then you can retrieve. In this case, I'm retrieving 6 goals that I have in this document. So once I have connectors to the documents I want to connect to, then it comes the need of creating traceability modules. A traceability module is just a module which is connecting both source and target of a trace, like a document, right? So in the definition of a traceability module, I must provide the name. I can decide which type of traces I enable here: validation, verification traces, allocation, flow down, whatever. You can add your own type of traces if you wish, right? So I pick here these 3 or derives, that's derive, and then the description is optional. And then here I have to just out of all the documents I have connected. If you remember, a DOORS project, then I have all the modules in this DOORS project, and then some Excel sheets with the risks, with the tests, and some stakeholder requirements as well. So I just pick the source and the target for my trace, and I'm done. So this is the only thing I need to know. I will explain later what is this, what are these other 2 elements in here, right? Let me move forward. Now, all my modules, link modules are created. So once the modules are created, of course, I can see this graphical representation that I was introducing before, or I can go inside one of these traceability modules. So when I open a traceability module, I have both source at the left-hand side and target at the right-hand side, right? I can see how many traces I have. I can find very quickly that all the elements in the source are traced downwards, let's say. I will show you now if all of them are in the target are also traced. So I can synchronize and say, okay, I want the source to be the master view, so that whenever I click on a source item, the tool can highlight the target items, or even the tool can filter so that you can only see the requirements that are linked to this element in the source view, right? So these are this is a way to very quickly find whatever element that you want to find, or you can have the master view being just the trace list, which is here below. So I move forward a little bit, and just to show you how the tool can react to changes in both source and target. I think this is the most challenging, changes in an unstructured document, but let me address this. So I am adding a new requirement, a new goal here, and I will be also, I have replaced, I have added this content. So the tool, the goal is now extended somehow. Goal number 1 has been extended. And goal number 2, I will be changing the text, but not the meaning. I have changed from should be capable of fighting to shall fight. So this is changing the text, but this is a meaningless change. The meaning of the goal is exactly the same as it was to be. It used to be, while the change in goal 1 was I included firmware, so it is a meaningful change. So what I want the tool is to be capable of distinguishing between these 2 changes, the meaningless change and the meaningful change. So first I refresh. Now I have all the new goal, and I have the new text in here in requirement. In goal 1 and goal 4. However, in the configuration of the module, you can distinguish which mechanism you want to use to the identification of missing traces. So if I go to the configuration and I go to the tab of suspect trace evaluation, then the tool will offer three different possibilities for me. So the first one is just to detect suspicious link just when the last modification date has been modified. In the case of database with requirements, normally this is when you modify any attribute of the requirement. But in the case of a Word document, the change of the date is coming with every change in the document. So if I enable this as a mechanism, then all the requirements, all the goals will be modified, will be represented as modified, while it is not the case. You can decide that every change in the text will be launching a suspicious element. But I prefer in this case just to say that I want to rely only on semantic changes. So I rely on the semantic capabilities of my tool. And then I have the configuration. Of course, there is no need to know the details of this, but just for advanced users, you can fine tune and you can decide in which way you want this to work. But normally, the default configuration is good as to behave in the way I was making, right? So whenever you close this, you can click on suspect evaluation, and then the result is exactly what I was expecting. The result is that the tool identifies the new requirement, yes, of course, but it doesn't identify any kind of suspicious link for goal number 4, because the change was just a static change or linguistic change, but not a meaningful change. However, the tool identifies that firmware has been added to this goal number 1, and that this makes that all the traces, 25, that are concerning this goal number 1 are now identified as suspicious traces. From here, as you can imagine, you can double click, you can one by one determining whether or not you accept this suspicious, and you transform this suspicious link into a regular link or whatever, and then you will find that as soon as you accept this suspicious link, you will have some of these rows turning back to white or turning or changing the status, right? So I move. I'm running out of time, so I go to be quick in here. Okay, then more advanced capabilities of the tool is the automatic, or of course I can show the, as I was presenting also in the slides, I can show the impact analysis for each individual element. I can have this graphical representation of the traces back and forth. So from a stakeholder 2, I can go to goal number 1, which is the source, and I can go down to the system requirements. If I just double click on the system requirements, I could drill down until the system requirements or whatever. I can group all these elements depending on the document that they belong to. I can follow all these links, and there are plenty of different actions I can do with this graphical representation of the impact analysis. Or I can also have a tabular representation of the impact analysis. If I just pick on the word product in here, I open the list of requirements in this module, and then in here I can see that this goal stakeholder number 2 derives from goal number 1, and that derives into a number of different system requirements. So I move forward a little bit. Of course, different views with the figures, just to check whether or not the traceability modules are complete or not. And then I have chosen two documents. One is system requirement specification, and the other one is the specification of one of the subsystems, right? In this module, I have decided to include 3 different types of traces: allocation traces, derivation traces, and flow down. And I would like the tool to automatically help me in the identification of these 3 types of traces, as I was describing in my previous slide, right? So I can work a little bit with this advanced configuration, so that I can request the tool just to identify first the flow down of requirements. Those requirements, like for instance environmental conditions that normally affect to the full system, and just need to be flowed down into subsystem requirements. I would like my subsystem to be capable of working at the same range of ambient temperature, right? So by means of just clicking or selecting flow down here, then I can click in there and I can ask the tool to identify those requirements that are fully equivalent or fully the same in both source and target. As you can see here, there is no need for these two requirements to be fully literally the same. In here, I used should. In here, I used shall. But of course, again, so this is not changing the actual meaning of the requirement, so that even if they are not literally the same requirement, the tool can think that these two requirements should be traced together. So the status of this trace is still suggested. Of course, I can now right-click and approve it, or I can do it in a kind of bulk operation. I can select a number of different suggested traces, and I can change the status for all of them in one single click, let's say. So the first approach was that flow down of requirements. Then we offer, as I mentioned in my slides, plenty of different mechanisms with these two options, and also what we call custom code tasks. This custom code allows first, out of the box, you have all this in your databases. As soon as you request a license of our tool, all this comes out of the box together with the ontology, and it offers you the possibility to, if you can create your own code in C#, it allows you to the tool behaves a kind of development environment so that you can come out with your own algorithm to suggest new traces, right? So you can, from here, you can execute one of the existing in here, or you can create your own traces. So in here, now I am executing the allocation, the property allocation method, so that for two requirements, concerning elements that are in consecutive layers of the composition in my PBS, and concerning the same property, let's say the weight or the power consumption or any other physical property, I want the tool to identify this and suggest an allocation. So I click on the cluster and on the PBS that I want to follow, and the tool automatically is detecting two new traces for me. So when I exit this screen, I can see my two allocation suggested traces in here. The same, I can accept or I can reject or whatever I wish. In here you can see how what is the formalization of this, but of course this one is speaking about the power consumption of the entire system, the temperature warrior. And to the right, in the target, it is the power consumption for one of the subsystems, the control system, right? So clearly, this two requirement has to be traced. So from here, I can disregard this suggested trace, or I can accept it if I wish. So I move forward, and I work a little bit with this with the configuration of the semantic engine, so that now the tool is suggesting me more elements, more pairs of elements that are to be traced, like these ones that are representing. If I go here, great. So in here, these two requirements that has been identified are speaking about the same state in both in the parent requirement and in the target requirement. So in the source is telling us that the temperature warrior shall be able to control the minimum temperature threshold if it is not that it is not exceeded by shooting itself down, while the target is when the minimum temperature threshold is exceeded, the control system shall shoot down the temperature warrior. So these two requirements are clearly, or should be clearly connected by means of a derivation trace, and this is what we have. The tool has suggested the trace, and of course I will accept this trace. And the same for the others, right? I will skip a little bit. So my final derivation of requirements is indeed, it is not a derivation, it is realization, because I have system requirements at the left and a Capella model to the right. I have here the different logical components, physical components, and so on and so forth. So that as soon as in here, in a requirement, I'm naming the name of a state or the name of a logical function, whatever, then by applying this other mechanism here, which is coming out of the box, then you have a number of course, a large number of suggested traces just due to the fact that name of a state or property or function or logical component is named in my requirement. Of course, it doesn't mean that you should approve all of them automatically, like as they are, but at least having the suggestion allows you to go right to the point and to have a quick definition of your traces. And then finally, the reporting. Our reporting is based on for this tool is based on a template in Word, so that whenever you install the tool, you will find this new ribbon here, Traceability Report. From here, you have a number of different attributes that you can just pick for your document. So this is a typical normal document, but some of the contents of this document, like this one, are fields that will be populated when you execute the report. So all these fields are coming from here, from the top bar. You just pick the elements that you like, right? You can add it whenever you wish in the document. And another important topic here are the iterators. So there are some blocks here that are iterators, right? So in case you want to have a section for each of the projects, you can iterate the projects. Normally, you will just report one single project. So normally this is not used, but in case you need it, it is there. But normally you will be needing something like, for instance, a section in my document for each of the traceability modules. So in order to do so, you just add the iterator for all the modules. Then all this block in here is a module iterator. So all this block will be repeated for each of the different modules you have. So that inside the block, then you can use any of the attributes that are listed here in this block. Every of these attributes can be used within this iterator, so that you can have the name of the module here, the description, the number of traces, and then for both source and target, what is the name of the source document, the name of the target, the number of work products in each of the in both source and target. So all this information can be listed here. And then, of course, a module is conformed of a different number of traces, so that we have included another iterator, now iterator for traces. In this case, this row will be repeated for each of the different traces I have. So so if I have 60 traces in a document, I will have 60 rows in this table, including the type of relationship or the type of trace, the state, the ID of the source and name of the source, and same for the target, right? So if I now go to the tool and follow this reporting wizard, then in here I can provide a reporting based on DLLs or just the map, the project map. But I will choose this option for a Microsoft Word template, and I will pick my template, the template I have just created. So whenever I click on there, it can take some seconds or even some few minutes, a couple of minutes. But at the end, you will have your document. It looks the same, but now the document has populated all the information. So this is the actual name of my project, so that I can scroll down a little bit. The table of content, I have included the project map. Of course, it is an object, a graphical object that you can manage as you wish. You can rotate or you can do whatever you wish. Or you can scroll down and have for each of the modules, you will have all this information. And then for module 1, all the 60 or something traces that I had included in this document, in this module, are listed here. And that's all for my demo. So now I send this back to Cecilia, so that she can close the webinar. Cecilia.
Okay, thank you very much, Jose. Jose will answer your questions in a couple of minutes. So if you want to ask him anything, please write down your questions in the chat box, and remember to address them to the reuse company or to everyone and not directly to Jose. Meanwhile, I will tell you about our next webinar. It's called Requirements Authoring Tool for Capella, the perfect way for blending models and textual requirements. While model-based systems engineering and requirements engineering are usually opposed as a means to support complex systems development, there is a growing trend in considering the combination of both approaches. This webinar will introduce the new version of the RAT authoring tool add-on for Capella, which goals are to ensure the correctness of the requirements created inside the Capella project, to help requirement writers follow predefined patterns to standardize well-formed requirements, to ensure naming consistency between the model elements and the textual requirements, and to provide a complete round trip between textual requirements in requirements management systems and models in Capella. The dates for this webinar are the 21st and the 22nd of April. So let's see if we have any questions. Aiming at the certification of a system, does Traceability Studio reach until the source code?
Well, not in this version. However, in the next version that is expected, as I mentioned, in 3 months' time, then yes, we have a number of different languages that are supported, so that you can, for instance, trace from a high-level need all the way down to a property or a method in a class or a class itself. So this will be, it is coming very soon.
Okay, thank you. Can you name other automatic methods that the tool includes today to detect new traces?
Well, I don't remember by heart. I know that we have all these methods that I was presenting in the video. We have a couple more. I don't know by heart, but they are based on the ideas that all these, by the way, can even if you see something like 4 or 5 different methods, but all these can be applied in different ways. So, for instance, I can apply a method that based on matching patterns and clusters. I can apply them, for instance, to identify 2 requirements with a common condition or 2 requirements with a common action. So, for instance, suppose that from a system level to subsystem level, you want the tool to highlight automatically those requirements that are sharing the same action. To detect or to launch or to whatever, so that you can inspect and decide whether or not they are linked together. So the idea is that the same method can be applied depending on the pattern you use and depending on the cluster you use. And these both pattern and cluster are just the input parameter. Then depending on that, you can execute, you can have different executions with let's say with different goals just by changing the input parameters. So it is not only the point of how many methods we have, but it is that depending on the input parameters, the target could be different. So this is the one based on pattern matching. So if I can instantiate this method with different patterns and different clusters. So different clusters and different patterns will come out with different results. The same method, but different results. So the idea is you can extend this as you wish. And of course, you can even have the possibility to provide your own method by injecting code that will be precompiled and stored in the centralized repository.
Okay, thank you. Next question. I don't remember, but when talking about trace suggestions, you only mentioned traces requirement to requirement. What about requirement to test cases?
Yeah, the tool allows for any different type of traces. Let me close this. If I go and pick all my modules here, then let me look for it. But I have here I have acceptance traces as well, so I can link from system requirements to test cases. In my case, system requirements were in doors, while the test cases are in Excel. It could be in a test management tool. In this case, they are just part of Excel. So the idea is that you can trace all this. You can trace either manually or you can apply any of these mechanisms to have the tool suggesting you new traces. But normally, the suggested traces work better or are more aiming at identifying traces among different levels of requirements. But at least manually, of course, you can do that. You can map into requirements too, and then you can show traces from requirements to models. Sorry, to test cases. Having automatic generation, yeah, it could be. Some of the algorithms we have today allows us to do so, or you can create your own algorithms. But at least manually, of course, we have the possibility to do so, right?
Okay, thank you. No more questions, so thank you everybody for attending. If you have further questions later or want more information about our tools, don't hesitate to contact us by email to contact@reusecompany.com or through our website, reusecompany.com. Thank you very much and goodbye.
Thank you, everyone. Take care. Goodbye.